noise. The acceptance of wind turbine technology is an European and more as an European issue. It's really a problem to get acceptance for wind turbines onshore. In Germany, the 1 kilometer distance rule to living places is really a problem. I will talk about noise here. I will not talk about shadow casting, and I will not talk about clouding the landscape. Wind turbines onshore you can hear, with residents are annoyed, and there's a question how to reduce this hearable noise and what kind of noise is it what you can hear. I have done a simulation for this, and here you can hear the noise of a wind turbine if you're very close to the wind turbine, and you can see the red curve, the unweighted spectrum, the blue curve was the A-weighted spectrum, and in the spectrum you can see the rotational frequency, more accurate the blade passing frequency of the wind turbine. 0.5 Hertz in that case, and the frequency resolution of this analysis is 1/8 of a Hertz. And interesting is that this low frequency, this blade passing frequency, this rotational frequency is from point of energy distributed along the complete frequency spectrum. Only if you manipulate the signal with an overlay of other sinus signal here shown at 100 Hertz, then this modulation frequency occurs, or if you have a DC offset of this pulse signal in the time domain, then you have a low frequency noise. So that is interesting from the point of discussion of infrasound. Yeah? It makes no sense to name it infrasound because the energy of this low frequency is distributed over a wide range of frequencies, the complete frequency spectrum. But I will talk now about the cause of this noise, and the hypothesis is that it is blade tip vortex noise from the wind turbine. Here some internet results measured with beam forming methods, or commonly named acoustic camera. Also here you find a lot of information about it. Also you find measurements here from a damaged blade with a hole inside, which makes a very loud noise. Yes, first I have done a simulation of a blade tip with a symmetrical profile, and there it's interesting, it's visible that there is no vortex like in the sketch of the DLR of the German Aerospace Center shown. There is no vortex, but I've used this information and I made a kind of reversed engineering. So how can I generate a vortex with a symmetrical profile? It's possible if I place a rotating cylinder with wall friction in the blade tip. In a 3D design environment it's quite easy, and I've done it, and here the tip vortex is visible. I've placed a rotating cylinder here. The meshing is shown, not a very nice meshing. I have used it in a way that I can use it for my lectures and the student could use it, so it's limited, but it's already everything is already visible from the from point of physics. I'm using the so-called Q criterion to visualize the vortex. It's the rotation of the velocity. I will not go in further detail. I will talk now about this vortex, and the idea is the vortex which is naturally there with a non-symmetrical profile, which has lift. I will reduce with a rotating cylinder in the blade tip, or I will not reduce it only with a rotating cylinder. I will reduce it. I will reduce the vortex intensity, and I show you different possibilities. Here I have reduced already the vortex with the rotating cylinder in the blade tip. Summarized, the results are here. I have to apologize for the German talking, but I am using all these things also for my lectures, and I haven't changed it here. And it's quite nice visible how the vortex occurs. There the vortex with the rotating cylinder is shown. The big vortex is completely eliminated, and you can see the streamlines which are transporting fluid from top to the bottom side, to the pressure side, right opposite to the natural flow along the blade tip. You can download this presentation, and here several views are possible. My talk is not a scientific talk. I just want to give you a lot of information, and you have to download a paper, and you have to download the presentation, and could go in more detail. In the internet you find quite interesting ideas to reduce this wing tip. So it was not only I'm not the first who has the idea to reduce this blade tip, and it's quite old. Here a guy had the idea to place some propellers at the blade tips. Here someone had the idea to reduce the energy with a rotating turbine. And here the nice design for the blade tip shape from a French engineer. It's 20 years old patent, but it's now free, so it's for use. And I tried to influence with very simple CFD simulations my tip vortex. I name it Catch the Vortex. I have used a cone, a closed cone, an open cone, similar to this French idea, a wing, and I opened that wing on the bottom, but still the vortex is there, so Catch the Vortex was not so good working. I had a view in the internet, and I found a lot of other things: spoilers, winglets, sharklets, spiroids. A lot of things are already tried to reduce the blade tip vortex, but the aspect of noise reduction was not in the focus. I have compared with a silent owl flight, and tried to apply this bionic design to a technical design. I made slits in the profile wall here in different ways. I worked with a winglet similar to the flat plate, similar to that what you find on airplanes. Wind turbines already has something like that. I have done the combination of winglets and these slits, and of course all the time I can influence the vortex, but the big vortex is still there. There's a combination. It's a still reduced big vortex, but I don't know what kind of noise production here occurs. That needs further investigation. Then I tried to build up a kind of technical feeder. That's the first try. It's a simple try, and it's visible that the big vortex are reduced, are divided into smaller ones. And the overall level intensity of the big one is reduced, but improvements are necessary and further research is necessary. Then I have tried to come from the symmetrical profile without lift and without a tip vortex to the non-symmetrical tip and with vortex, and I investigated a continuous changing profile from the asymmetric to the profile, and that reduces the vortex length. So that is the right way, this smooth transfer of the blade shape, which is shown here again. Yes, the symmetrical side, the non-symmetrical side, and the design has to be something like that. Further investigations are necessary. If you compare the noise of the wind turbine with infrasound, then I would like to say here, and that is everywhere demonstrated in the internet, that the infrasound which you have in a car is much, much higher than the infrasound or the sound of a wind turbine. And I have shown at the beginning that this infrasound is distributed. Yeah, the sound of the rotating system is distributed over the complete frequency spectrum, and it's not a single frequency in the low frequency range. That occurs with the cars. The noise level of wind turbines is compared here with streets under rain conditions, silent conditions, very, very silent conditions. And the question is which distance you need. Here 600 meters are a nice distance, or 700 meters, but the best would be that you reduce or eliminate this tip vortex noise, then nothing is hearable. Problems with all these noise measurements are that standardized measurements are complicated for wind turbines, and they produce nothing on progress for the residents. And the determination of large machines is in general, the determination of the sound power of large machines is in general a big problem. Just in comparison, for the wind turbine, no one measures the sound which is radiated from the top, so from upwards the wind turbine. And normally you have to place a complete envelope around the machines. And for wind turbines it's tricky, because if you have high wind conditions, then the wind noise covers everything. You do not hear the wind turbine. The problem are the low wind conditions. The low wind conditions where the turbine is still operating and producing electrical power. So the low wind speed condition has to be in that range, that they are fast enough for electrical power production. And then it's silent, and then residents are annoyed. I would like to finish all these discussions, legends about infrasound and so on, not useful, not helpful. There are a lot of strange investigations of the heart muscle. My question is, what are with all these drivers of automotive cars? There's a lot of infrasound in the car, and no one has heart problems. In Düsseldorf, we have quite good experience with reducing noise. We have worked on so-named leading edge serrations, which are the technical copy of tubercles from a whale, or they are also similar to the leading edges of the barn owl, which has a very, very silent fly. And we have done research over several works. Till Biedermann has written his PhD work about it. And I found legends in the internet that these wakes of wind turbines are over 70 kilometers 70 kilometers away. You could feel them. Please, no, I don't believe, and I think this picture shows a different thing. Yeah, but is it really legends? Is it really science, or are it legends? And is it really helpful? Yeah, of course, there are problems with wind turbines. Yeah, I have reported in 2013 about something which I found in the TV, that there were cracks in the wall. There were real. Yeah, of course there are problems. Yeah, and often, nearly for all these things, you find technical explanations, and there the tower was swinging, and the tower was in this area transferring the waves in the ground, and so there was a problem in the house. Yeah, it occurs, but it's not related with infrasound. And just in comparison, we have infrasound problems from industry. Yeah, but all the time no concern, because we have a standardization and the measurements show everything is in the limit. Yeah, so do not talk about this in a way that it's only for wind turbines a big problem. I can show you industrial companies which are distributing such noise. Here it's in a flat, and then we were walking close to the company, and it's getting louder and louder and louder. Yeah, and if you have detailed views here, 2 machines were running in a foundry, and yeah, it's possible to explain the technical. And here in a weaving mill, you could see each machine which is working there, and the material for the fabric is blowing in the machine with high pressure under high pressure conditions, and each peak is a machine which is running in this big company. Yes, the interest of the wind turbine industry is to sell big and expensive machines. So most of the big companies are focusing on offshore machines. Already in 2013, a research head of GE Global told us they have finished the development of noise reduction for wind turbines. Yeah? And is it is it the right way? Of course, Germany has lost a lot of jobs in wind turbine industry, but we need the onshore wind turbines for our energy change. And come on, small wind turbines on houses, that is not the real way to solve our problems. Small wind turbines needs high rotor speeds, and they need a lot of maintenance, and I would just say they are dangerous. The problem is that you hear wind turbines currently. Research is necessary. We at Düsseldorf University of Applied Sciences, we would like to work on it. We need foundation, we need partners. It is necessary to reduce this tip vortex noise, this whoosh whoosh noise. And in a second step, in collaboration with psychologists and doctors, it's still necessary to discuss infrasound and to eliminate the legions of vibrating walls and 70-kilometer propagating vortex structures. Yeah. Here you can download this presentation, and there's also a paper available. Thank you for listening.